Awesome. Thanks so much, Brian. So thank you everyone for joining today. This topic of Jamstack of databases for me has been a long time coming. So I was first introduced to Jamstack a few years ago, probably like 2016, 2017. I saw them as these like very static sites, like documentation or a marketing site. But really in the last few years, I've begun to see them as this much more like dynamic application, seeing like large corporations building whole like web applications on them to smaller companies doing some really interesting things with them. And so I wanted to dig into this topic of like where do databases fit in the Jamstack? So first, I kind of want to set the context for this talk of what is Jamstack. I imagine if you're joining this and if you've joined any other CFE dev talks, you know this, but I think it's important because it kind of sets us up for this topic of where do databases fit in. So the three parts I think are always really important to remember is, pre-rendering as much as you can at build time and then putting that in a CDN and then rendering everything else later. Building as much upfront and then pulling data as needed is a core part to Jamstack. The second is most dynamic functionality is via JavaScript in the browser. So there's a lot of JavaScript kind of conversations throughout this talk. And then the third is server-side processes are abstracted by reusable APIs. Now, this could be an external third-party API that you're using. This could even be something you build yourself, which is less of a conversation and will be a large part of this conversation. But really, the idea about using third-party is you're leveraging domain experts who offer these products and services via APIs that allow your team to kind of have these like superpowers and not have to worry about them. It reduces some of the risk of what your team is maintaining, just some of what is required to build. And I think that is the part of Jamstack that I've always really loved is the API part. I come from a background of backend engineering and caring about APIs and API design and how APIs are used and how they've just expanded so much. And so that's always been a very interesting part of Jamstack for me personally. And with this, I think the most important thing, though, to remember across this whole talk and just about Jamstack in general is Jamstack is all about decoupling. Changing out a service or changing out an API should not feel like surgery. It should be easily changed where we host something. It should be easily done to change what API we use in our application. Not everything should be strongly tied together and heavily dependent on each other, which was a thing more of the past. Often when we hear APIs in the context of Jamstack, we think these external services. But again, it's really about just server-side reusable APIs, whether that could be an external service or a serverless function that you're hosting on Netlify or Rochelle or wherever. So how did we get to this point, though, of wanting to decouple these things? I think it's really important to understand to where we came from to how we got here today and all these different types of rendering. So basically, this sits on top of a brief history of web stacks. I'm going to go through each of these, so I'm not going to go in detail, but in the late 90s, LAMP stack was really popular. That's Linux, Apache, MySQL, PHP, and then sometimes Perl or Python. Later came mean stack, which was Mongo, Express, the JavaScript library, Angular, and then Node for the backend. And then came Jamstack. But how did we get from each of these places? Because I think all of these kind of build up to what is Jamstack today. So the early days, we had a browser that acted like a client for the user. We requested some page. It went to the server, got that page, returned it, and the HTML was rendered in the browser. Then we started wanting to do more complicated programs. And so then we added a PHP program in there. And then, that PHP program needed to connect to a database server. And so, same thing. User requests something, that server goes to and this is wildly simplified, I will say, but for the purposes of just understanding high level, went to the program, and that program went to the database. Now, this is a lot of server side rendering. We're doing everything on the server side, and we're actually accessing the servers directly, and we're installing and maintaining and operating all the software ourselves. We started seeing, maybe there's ways we could improve the performance between the program and the database. That's where caching came in. Let's reuse some of the data that we're requesting all the time so that we're not slowing things down. Then this idea of content delivery networks, or CDNs, came in. Quickly be able to transfer static assets and put them around the globe so that we can skip the server step a bit more. And with all of this things became more complicated. We added in load balancers so that we weren't overloading the server. We, needed to scale, and we had reliability issues, and just things became more complex. We're having to maintain more. We have to worry about security. There was just a lot of things going on there. And later then came MeanStack. So, this idea of client-side rendering came to be. There's more JavaScript. JavaScript was really having a moment around this time. A lot more JavaScript in general, Node becoming really popular. And in some ways, things kind of maybe improved in some ways, but in other ways, things got worse. Things got slower because of this blocking nature. You got to download the HTML file, and then you need to download the JavaScript and the CSS, and then it has to be rendered in the browser. And there's just a lot of things that could be blocking in nature. Platforms like Google App Engine or Heroku, if you've ever used them, were less interacting with the servers as directly. It was these like platforms as a service. I came up in full stack development in the age of Google App Engine and Heroku. I thought they were amazing because then I didn't have to go understand how to do like complicated Apache server stuff sometimes, or didn't have to worry about server maintenance to the same degree. And it was really awesome. But again, these performance issues and all of the other issues we had before with reliability, security, like they didn't just disappear. And towards the end of Mean, we had a lot else going on in the web development world. AWS Lambda was released in 2014, so that really like serverless came on the stage. GitHub was becoming way more popular. I was moving from like SVN to GitHub, so then you could start having these like Git workflows. And if you don't know what SVN is, be happy that you don't know what SVN is. And APIs were exploding. You could send text messages with APIs and not have to maintain your own mail server with an API, like SunGrid. And all these things were coming to be. Build tools were maturing in the JavaScript world. CDNs, which already existed since Jamstack, were kind of having more innovation in how they worked. And static site generators, which also existed for a while, also had their kind of like next generation of them coming. And this idea of like different types of rendering, not everything has to be client side or server side, came to be. Performance was improving, especially with Jamstack. But at first, again, it was still mostly seen with static sites, but now it's much more dynamic. I really like to show this graphic. You don't have to like read this whole thing. You can go to the URL in the Google developer docs and read it, because I really think it demonstrates like the wide spectrum that Jamstack like offered us in terms of rendering, that before wasn't just one-sided or completely on the other side. There's a lot more hybrid models now with how you render things. I'm not going to dig it all in, but I think the more important thing to remember is, you really pick the right type of rendering for the job. And so it takes some thinking of what actually makes sense. What are we doing just because it's shiny versus like what does actually serves the users the best? It's really important to remember. So we kind of understand like, okay, we had all this complexity. We started decoupling things to make it slightly less complex, more portable, easier to work with. And if Jamstack is all about using APIs, like where does like a database fit into that? And the reality is you can do a lot without a database. There are tons of Jamstack applications where a database just does not make sense, like having an actual relational database involved. The right combination of external services, APIs, third-party APIs is often, maybe the solution. But what if you're building something like the Planiscale web app, for example? It's Jamstack gets built on top of Next.js, or anything that goes beyond just, maybe some content from a CMS or login or payments that you would use a third-party API for. And so I think it kind of breaks down in a way that I really tried to demonstrate it here, but it's a little tricky because using a database is often based on what are you actually building. Um, the best way I can summarize it is, are you building some kind of core business functionality that isn't served by the standard APIs? Maybe your application has, you're building out user accounts for a new business that you're building, and it doesn't make sense trying to shove it into an existing service. But at the same time, like, you're not going to reinvent authentication or how to do content management. You're not going to reinvent e-commerce or, any of the amazing APIs that are out there that are just like standard across companies. If it's unique to your business, maybe there is a role that the database plays. Think about just how your accounts are structured. What is the thing, the app, the product, the business actually offering? You're often building things that have never existed before, and that, you need a database. Authentication, CMS, all those things, those are built on top of a database too. You just don't see it. And so sometimes you have to actually use a database to create something brand new. And so even when the use cases are pointing like, yeah, I think we're going to need a database to store this information. There's no APIs that are going to serve us for this need. Not everything always fits into a relational database model, but a lot of them do. So when does it make sense to use a relational database? I think the most important thing I love to tell people who are newer to thinking about relational databases, like, think of a table-like structure, like in an Excel spreadsheet, for example. You have these columns, and in a relational database, those columns are all of one type. You can trust that your name column is never going, will always be a string. It's not going to suddenly need to become an integer and make it harder to query across all users, for example. And this helps us have less concern about consistency because the database schema is enforcing like all names are strings. And if they're not, it's going to reject that. And so, the data in this relational model is regular, it's predictable. Data integrity and consistency are important because then it makes it possible for you to easily query. Sometimes in a non-relational database, it is harder to do certain types of queries. In a relational database where there's this consistency and things are organized down into tables, it's a lot easier to query across tables, to join them, do more complex queries across tables. And this is all due to being able to rely on that consistency. There's other operational benefits of a relational database, such as MySQL. You get things like backups and replication and failing over if it goes down, and how do you upgrade it? This is across many relational databases, but I didn't include it here because it's more on the operational side of things. But then those can definitely become important down the road as you scale. Again, just like nailing in this like idea of this spreadsheet like view of a table. You have a student table, and you can see this like column like structure. It is part of a larger data model that has other tables, and there's relationships between these. So like the student table, for example, is connected to the student section, and that section is connected. Student section is connected to the section table, and having these, being able to map them out like this makes it easier to query later, and just have trust that consistency again. One important thing, I just want people to kind of just stop and think, like, what is something that you're working on that's new that maybe fits into this model? Like, where are those clear relationships between things? Could you draw something like this out? And do those data types, stay pretty consistent? Then you have a great case for using a relational database. I think one of the reasons why I wanted to give this talk, because even myself had this like misconception of like, where do databases fit into the Jamstack? Like, can you actually use them in Jamstack applications? And the answer is overwhelmingly yes, but because of the APIs and how do you connect to them kind of always made it like a fuzzier thing. So I want to look at how that is even possible to connect between these two things. For example, I want to look at specifically Next.js. I'm picking Next.js because it's one of the most popular Jamstack frameworks. Probably pretty popular JavaScript framework today too. It's built on top of React. We'll talk about some of the differentiators about it later, but I think it's a really good example of all the different ways you can actually connect to a database and where you can do that in a Next.js application. There's actually 4 different places you can do it. Some of them make more sense than others. For example, the first one, build time with get static props. This would not work well if you have data in a database that's changing often, because you would actually have to rebuild every time to pre-render that data and get it out. It's less dynamic. So the data wouldn't really be able to change much, which isn't a great example for when you want a database that's pretty dynamic. The next one is at request time with get server side props. This is more dynamic, but it also has less decoupling because you're tightly paired with the code by using get server side props. The fourth one is API routes. Again, this going to this idea of these server side processes that are part of Jamstack that are decoupled. I think I'm a big fan of using API routes. I'll later actually have some resources about showing how to do this more. But yeah, Next has this great way of doing file-based routing. So you literally drop in a JavaScript or TypeScript file in the API route and add minimal amount of code, in my opinion, compared to other APIs I've written. And you already have an API that can be hit by anyone. And then the fourth one, which is a little bit different, you separate out the API backend altogether. You have a totally separate backend server that has an API running on it. For example, at PlanetScale, we have a Next.js web application, but then we have a Ruby on Rails API that is living separate. And we call it just like we would call like an external third-party API. I think, I gave it away, but like my favorite is definitely API routes. I tell people, what if accessing a database was just like working with like a data API? Many people think you need to have a query API built into the database itself. That's not entirely true. You can basically create your own that serves the need you have. And these API routes get deployed as serverless functions. And there's that clear decoupling. So say, for example, I wanted to change what database I was using entirely. I don't have to mess with what parts of my application are using that API. I can just change the actual API code itself and, have it give the same response it gave before. And the end user or the end consumer of that API endpoint would have no idea that it even happened. I think that's really cool to have just that flexibility. Oh, and the other thing I missed one thing I want to say. The other thing is like I think it gives the best blend of like developer experience of using the API routes while also getting you started like right away. But it also scales fairly well. Sometimes it makes sense eventually to split it out entirely, depending on what your business is, what the requirements are. It gets into some details, but I think it like I can get started with these API routes super quickly, which makes it awesome. Now, with Jamstack, the shift from LAMP to mean to Jamstack, there comes a few changes in what we need the database to actually be able to do. That maybe before we had less of an issue just because of the style of the architecture. So I have 6 different ones I want to go over. The first one is connections. So having the ability to have support for high number of connections. Jamstack applications need a lot of database connections. But why? Relational databases like MySQL or Postgres use this very long-term transmission control protocol, internet protocol connections, or you might have seen TCP/IP connections. You don't need to know super details. You can go look that up if you really want, but they use that to connect to a database server. It's its own protocol. This is a bit different than the HTTP protocol that REST API might use over TCP. And behind the scenes, though, these are these short-lived connections to connect to a database, get data, store data, and then they close. These short-lived connections can really add up over time because every single user of your application is potentially triggering some serverless function that connects to the database to return or store some data. Sometimes one user could have multiple connections, even depending on what they're doing. They really add up. And a lot of database providers either have limits on the plan, like you get X number on whatever plan, or they cannot support a high number of these connections. You do have the option of getting into this idea of connection pooling and all these other things. But again, Jamstack, we don't want to care about these server details. So I wouldn't want someone to have to go implement how to do a connection pool to share these connections just so that they can access their database. The second one is hosted and serverless. One of the major benefits of Jamstack is that you're not dealing with this toll of managing servers. So why should you have a database that is requiring that of you? There's also this idea of portability through standards. I like that I can take a MySQL or Postgres database and switch providers. I don't want to be locked into some proprietary thing where I cannot easily change my database provider, which again, Jamstack really encourages that portability aspect. You want to be able to scale up and scale down. I don't, one of the things when serverless came out, it was you don't have to have a server that's always running, that has certain types of resources available. You want to be able to when you have spikes in user traffic, be able to handle it. And then when it goes down, you want to be able to not only handle it, but also not be paying for what you had at the highest resource. And so a database should also be able to have this flexibility of going up and down. And with that also comes being always on. If you've ever used Heroku, you may know of this cold start problem. Back when many of us were deploying applications to Heroku, we really started realizing it when we tried to build Slack bots, because if the bot hadn't been used in a while, it was cold and it took a little while to get started again. It was painful. Sometimes people would just write programs just to ping their Heroku app so that it never went down. We need a database that can be, immediately queried, immediately have data stored in it. We don't want that cold start problem. And then there's latency. So what is latency? Latency is the time it takes for data to go from one point on a network to another. Jamstack prides itself in this amazing performance because these static assets are stored on CDNs around the world, and it makes it super fast. And so we need a database that kind of still fits that need, especially if we're getting data at request time. We weren't able to pre-render that data. We need a database that doesn't just slow everything down to a halt. This can depend on a lot of things. It can depend on the database you're using. It could use where it's located, what your caching strategy is with accessing data, a bunch of different things. But it's important that we don't want the database to be the major bottleneck in our application. And then the last one is analytics you can actually understand. So with this move to serverless, we extracted a lot of things away. We don't care when our apps are hosted that, how much CPU it's using on some server that we don't even have access to, or any of these types of details. But at the same time, you could still write a query that's really inefficient, that's slowing things down. And so we need analytics to be able to communicate to us as non-database experts how things are going, where can we improve, and just not leave us being I have no idea. I need to be a DBA, a database administrator to like understand what's going on in my database. You shouldn't need to do that. Jamstack doesn't expect you to be a backend server expert, for example. And so database give us metrics and things we can actually be useful with. And so those are those 6. There's of course plenty more. There's operational challenges and others. But I think those kind of hit on like the major pain points that if a database can't offer us this, then we're going to have some trouble. The last section I want to touch on is how to get started with, Jamstack and databases. I have a preferred stack that I'm going to share. It's maybe slightly not totally impartial because the plain scale is the database there, but the Next.js and the Prisma part are decisions I've made. I'm going to walk through those, but first I want to give a few. I tweeted a couple weeks ago, like, why do you like this stack? Because people love to rave about it, and so I wanted to share from some users of the stack why they picked it, rather than it just only coming from me. I'm going to read from my notes. MVP to scale with the same stack. So meaning they could just be prototyping and then they could, actually have a launch product that grows on the stack. They feel like the tooling gets better every year. I'd probably say maybe every month at this point. It's moving pretty quickly, which has its pros and cons. Great docs, and mostly everything mostly just works, is what someone said. Another person said that scale without thinking about scale. So that's like being able to scale up and scale down, those kinds of things, connection limits, those things. And they get type safety front to back. So that means that they're often using it with TypeScript over JavaScript, but this stack has support for both. And whole category of problems removed by simplicity. So again, the serverless model kind of helping with some of that. And then the last thing they said, they don't need to worry about servers or connection limits. They can just deploy and forget. Yeah. And so let's break down a little bit why Next.js. So Next.js is probably one of the most popular Jamstack frameworks today, partially because it does support a wide range of rendering, these like different hybrid models of rendering. There's some awesome talks out there that break down all these different types of rendering. But it has support for all of them. It has the ability to create API routes that run as serverless functions. It has portability. You can switch providers. If I'm on Vercel, I can go to Netlify. If I'm on Netlify, I can go to Vercel. And others are popping up all the time too. It's got a large community around it, and it's just very heavily maintained. Now, if I was looking for alternatives, there are a few alternatives. Closest alternative I would say is probably Gatsby. They've done a lot to kind of also have some of these hybrid rendering models. 11t, which isn't exactly a one-to-one, like I can't totally replace everything, but 11t did just release serverless function support. I've been doing static sites on 11t probably for like 4 years now. And so it's always been a special place in my heart for static sites too. And so I was super excited to see about the serverless functions. And then you kind of have like the outlier, which is Remix, which is a newer framework. It approaches a totally different model. I'll include some resources about Remix because that's a whole thing to explain how Remix differs from like a Next.js, but I figured I'd mention it. The next thing, Prisma. Why did I pick Prisma as my ORM, which an ORM, just in case you don't know, stands for an object relational mapping tool. Think of it as a database client that lets me connect to a database, store some data, query data. Prisma is a little different from traditional ORMs, which many languages have their own, many frameworks have their own built in sometimes, like Ruby on Rails has its own, Django has its own, like they all have their own default ORMs. Laravel has its own. Prisma is a little bit more declarative in the sense that you have this Prisma schema file that has these 3 things in it. It has the data source, which you can see is the first thing. I'm saying, hey, this is a MySQL database. I give it a connection string that tells me where that database is located, and some optional settings to that. Then it has a generator. So it's actually creating a client that helps me speak to the database. It has some settings related to that. This one is doing it in JavaScript versus TypeScript. And then the last thing is it has data models. So this would be a lot bigger. This is just a tiny part of it. This is a post model. You kind of describe what it looks like. I like it because it feels more like readable language rather than just like super code feeling. And it makes it easy to quickly look at a model and understand what's going on once you start like getting started with it. As I mentioned, it creates this client that talks to your database. This is a tiny part of a larger API route, a file in under Pages API. Of course, you need to like say what kind of route is it? Is it a GET? Is it a post? Is it a put? Like what kind of route is it? Some like try catch logic, all these things. But I really wanted to just focus on the part where you can just query get me all of the posts and it returns it in JSON, and then that can be consumed by your front end. What would be some alternatives if I didn't use Prisma? MySQL 2 is one. It's more like your traditional database client. You will be writing your own SQL in it, but it helps you do that connection to the database, which you could also put in an API route the same way if you wanted. And there's just other JavaScript and TypeScript ORMs out there that you can definitely explore too. Now comes the last part where I'm probably the least impartial. Why Planet Scale? There's a lot of reasons why I could say why Planet Scale. I think for this conversation, it's the being able to have the high number of connections, which is done because Planet Scale is on top of Vitesse, which is a project that was developed at YouTube to help scale MySQL at like YouTube scale many years ago. And many large companies use it, like Slack stores all their data in Vitesse, for example. GitHub uses it. I mean, like there's tons of companies that use it. It's serverless, of course, like we said that was like a given. But I think one of the other things is like it's Git-like features. So with Jamstack, Git workflows became like a really popular thing. And so our brain was kind of thinking in this branching model. And so PlanScale has this idea of data branching feature where you can branch your whole database as an isolated environment and develop new features and test. And then once you're ready, open a deploy request that sees if it can be merged into your production database and easily do that without locking up the database. And then if you're like, oh, shoot, I shouldn't have deployed that. I deleted a table. I deleted a column or something. There's a rewind feature that actually rewinds that. And the last thing is it's standards based. It's MySQL at its core. And if you really wanted to, you could go host it somewhere else, your MySQL database else. You might lose some of those features, but I think like just not being locked in is something that's really appealing to me. And so it breaks down to this idea of like scalability, but with developer experience. What do I mean by that? You get a feature set that helps you scale, like the connection and all those types of things, while having these developer experience features that also just like make it easier to use, make you work faster with less errors and problems. That along a serverless database that is managed for you. I often see with other solutions and just across the other developer tool spectrum, you either have to decide, does this scale or do I get developer experience? And I think this is kind of the best of those both worlds. So you never have to make that decision like down the road. I need something that actually scales. I have put up the slides for this talk on my notist. It should be like the first one right there when you go to that URL. I also have some links. I'm going to be adding a few more links that while I was doing this talk, I forgot that I probably should add, and how to get started. My teammate James Quick at Planet Scale has an awesome video about using Next.js with Prisma and deploying it to Vercel start to end, which I think is a great way to get started. And other resources. One of my favorite Jamstack talks, like how did we get here? If you're really interested in that history piece that I mentioned, digs a little bit more into it. And you can check those out. And I just want to thank you so much for listening to me for like the last 30 so minutes. It's really awesome. I really like sharing these ideas. I want to see more people using databases in their Jamstack applications, pushing Jamstack to be more dynamic. And I'm happy to help. You can find me on the internet. And yeah, that's it.
That was awesome. That was really, really great. So folks have been kind of quiet on the chat, but feel free, folks, to ask your questions and we'll get them answered. I do have a bunch of questions myself.
Okay, yeah.
So if they don't have questions, I've got questions.
I would love to hear your questions.
So one of the things I was thinking about is how folks don't need to, like, with Jamstack, it doesn't have to be, the database doesn't have to be all or nothing. Like those other stacks, it was like everything was in the database, right?
Yeah.
But like Jamstack, you can mix and match pieces of this. Like, okay, I could put my authentication stuff, data, like user data in the database, or I could use like Auth0 or whatever.
Yeah.
Like, so you can kind of still rely on those services,
yeah,
but have a database for those parts you need a database for, right?
Yeah.
I think. Sorry. Do you have any thoughts on that?
Yeah, no, totally. I've seen some interesting things. There's this library called Next.js that it's almost like a hybrid of those two. You're using other auth providers in a way. So like, say you have an app that you literally can pick, I want Google, I want GitHub, and I want, I don't know, Okta or something. And you can actually add that in and there's a Prisma adapter. I forget, that might be the wrong term if it's adapter, but it's like, here's the schema that you just literally paste into your thing and you set up the Google stuff. You create like an OAuth app in GitHub and do all those things. And then you have auth with other providers. And so it's almost like this best of, it is like, these models are still in my database and I can connect users to them while still like not having to do the whole auth thing yourself. And so it's kind of, again, like hybrid models of this. Or you could just flat out just go use Auth0 and only have that up. It's like you get that option.
Right. Yeah. No, I think, that's one of the things I love about building Jamstack apps is that flexibility to kind of mix and match pieces as I need to. Back in the day, I remember doing like databases were something I knew well, but like were also the bane of my existence because
I think that's most people's experience. I think with them. I think and one thing I should have dug a little bit more into now, I didn't totally mention, but like for example, I think Prisma has made it more friendly for like someone who was more comfortable on the front end to do database related things because of just the declarative schema. It's like easily readable, just like a really good developer experience for JavaScript and TypeScript. I mean, of course, there's like those challenges, and this goes to like analytics you can actually understand. You can write a bad query with an ORM. Doesn't matter if it's Prisma or any other ORM. And like being able to actually understand like what is a bad query, like you shouldn't need to like have to deeply understand all those things, but you should like be able to like have some kind of tooling that's like, hey, heads up, this is you should like maybe go improve this because this is slow.
Yeah.
Versus you having to look at it and just be like, oh yeah, I know that's a bad query because you're a SQL expert. You shouldn't have to be.
Right. I remember like having to deal with like people not understanding the database and indexing properly.
Yeah.
And then they'd write a query that was like, it was like ungodly slow once the table got big.
Yeah.
And it's like, well, you're primarily querying this column that you never indexed. Like, of course it's insanely slow.
Yeah. Like, the index thing. Yeah. Like, we have some interesting ideas to like help people realize some of those things at Plan a Scale that I'm really excited about. It's not all out there yet, but I mean, it's like, it's wild how much just like adding an index can change things. And also just like, if you're ever using databases with like kind of the price model, that like an index can even save you a ton of money basically. So it has lots of implications of that, but yeah.
Definitely. So this fellow named James, he asked a question here. You may know him. Are there any new technologies that you're particularly excited about outside of Prisma?
I mean, I'm really just excited with what like Netlify and Vercel are doing with like edge functions and stuff. I think like these ideas of like pushing these like serverless, like, okay, AWS Lambda came out 2014. And for a while, I think people just there was like this is cool. They weren't actually using it in production. Now we're at the place that it's being used heavily in production. And now there's like this like second version of like, what can we do with like serverless functions? Can we write like middlewares to like handle different types of things, especially if you have like an API that you need like rate limiting on or something, like these like different things that make it more like the types of APIs we were writing on totally server side, where we're accessing the server directly on Google App Engine or Heroku, or even before that with like Apache and PHP and stuff. But like bringing some of these ideas of like better developer experience to write like legit APIs, like not just like toy APIs, like APIs that we can build businesses around that handle scale and stuff. I think there's a lot of cool stuff going on in that space. But yeah, that, and I mean, I'm also just excited about this idea that like the whole window of the stack has shifted. Like now a front end developer can do a lot more back end things today because of the tooling that has come up in just the last few years. I came in from a back end perspective, so like writing an API always felt like a very natural thing to me. I recognize that that doesn't always feel that way for others, but I think a lot of the tooling that's come up is helping that be more of a reality, so that a front end developer can kind of build almost more full stack like applications without feeling like they have to be a server side expert.
Yeah, I definitely agree with that. Because a lot of these pieces now, like you bring up Next.js, but even other frameworks, it's like building the API is kind of built into the framework. You don't have to, and then you bring in some other libraries, and I mean, you have an API. Although a lot of times you end up with this. There's an API and an API like the back end for front end pattern, which like I've looked into quite a bit in the past. BFF, But the other thing you brought up there, which is super interesting to me, is the edge functions, because I like how that plays into data has been a topic that's been fascinating me lately. Because you're now moving all this logic to edge nodes or CDN nodes all across the world, whereas in most cases your data is still located in a single region. Which, I mean, to be honest, for most applications is fine because you're dealing with that latency anyway. But like
that is, like a Planescaler point of view is often that like there's specific use cases where it makes sense to have like multiple regions for your data, which we like now have support for. But there's a lot of cases where that doesn't, and actually just like some better caching or like just being mindful. I think one of the things people just often forget is some of these platforms, your like serverless functions are deployed in one region. Where's your database? Is it across the country? Is it across an ocean? And they need to at least be physically close. So if you're in an AWS West for your serverless function, you need to also be in AWS West for your database. So it can do a lot of improvement on latency, just being physically close to where the function is running.
Absolutely.
And I think with cloud computing, we forgot that like physical location still matters. It's kind of coming up more with like the edge stuff. But it's been an interesting conversation. Even just like wanting to deploy serverless functions to multiple places at once has been a thing that some platforms support better than others. And I think there's like two things going on: all the innovation on like the compute side of things with the functions and all that stuff, and then the database side. And they're kind of converging, but also they're kind of have different opinions sometimes. And so it's been very interesting to kind of figure out like what are some of the good patterns to follow.
Yeah, it's definitely kind of like in an not completely settled state, obviously, right now.
Yeah. There's a
Because
ton of innovation going on
yeah,
in that right now. Yeah.
kind of overlaps with that discussion of like giving all these tools to front end developers to do stuff. And I'm totally, I love that because I'm mostly a front end developer. But like, but I also feel like sometimes it gives you power that you haven't quite fully like
Yeah.
thought through, which
Yeah.
is exactly this kind of thing. It's like, okay, now we've given you this super easy, you're deploying your APIs to,
Yeah.
simply, and they're probably deployed to like a US West one or
Yeah.
US East one or whatever.
Yeah.
Or maybe you have some control over that and you know where they're deployed. But anyway,
Yeah.
but now, okay, now we're going to give you edge functions. And by the way, those are deployed everywhere.
Everywhere.
And
Yeah.
that you haven't, in like what you do there with data, to me is like, start to think a little more carefully about like, okay, exactly what you say, the location matters. And like, yeah, so now they're connecting to a CDN location in Japan, but I'm in US East 1 for my
Yeah.
data. Like I've now made it like super far apart, whereas I used to have them kind of close together.
Yeah.
And it's not that not that there's something hugely wrong with that. It's just something I don't
Yeah.
think everybody, because it's so easy, I just create this
Yeah.
little middleware function and boom, oh yeah. And it's like I'm
Yeah.
not really thinking about like, hey, that
Yeah.
middleware function is calling an API that's living all the way across the world,
Yeah.
you know. Um,
Yeah. Yeah. I feel like until just the last few years, I wasn't thinking as much about all these. And maybe it's just because performance of applications have improved so much. So now that we're like more sensitive to
yeah,
the physical latency type problems that before we just kind of didn't pay as much attention. Maybe it's mobile devices that have really pushed it. Um, and some people say like, oh, internet is pretty fast now. I'm like, yeah, but not all over the whole world. And so there
yeah,
are some of those like still geographical type challenges that it depends so much on what you're actually building and for who.
yeah.
And
And
I think
I go
it's
ahead.
like the soft problems of just like who are your actual users that people don't always think about.
Yeah, and I should know you all have like portals, right? Portals is
Yeah,
what you
so
want.
that's the
Right.
region. Yeah, so you can do read-only regions. You
Yeah.
can, and it replicates the data around. But again, even when I was like writing the blog post for portals, I teamed up with a few different. I teamed up with an engineer on one of our teams that does a lot on our Ruby on Rails API, and so I had him help work on a Ruby on Rails example because Ruby on Rails has a way to like switch out which database you're connecting to, and so he did that based on um, what server it was talking to, so it would be really close together. And then we also worked with the fly.io. They wrote some examples because fly's really into the spreading around the globe, and so
Hmm.
they also wrote a guide on how to use portals with fly. And so yeah, but the reality is like not all the platforms really have the support that I actually need to like make it work in the most efficient way. And so it's been kind of interesting kind of seeing it all play out. But there's definitely people who have business cases that that stuff makes sense, but for the
Right.
average user doing a hobbyist application or even just a small side project that may turn into a business, like they shouldn't have to really worry about some of those things, I think, yet.
No, no, yeah.
But yeah.
But and even some of that little bits of latency, like it's we might be kind of
Yeah.
worrying about something that really isn't like that may not be the bottleneck in your
Yeah,
application, really.
exactly.
Like that little piece of
Yeah.
distance that is traversing there is not the real
Yeah.
thing making your application slow.
I think what people also like is they just like to know that if they eventually came down to and they were like, yes, this is a problem because the actual physical distance, like they
Yeah,
actually instrument their code and actually get down to where the actual root of the problem is, and that is like data latency. It's nice to know that they have solutions, I think sometimes versus being like limited by those. And so
yeah,
yeah, it's nice that the portals exist.
yeah,
Don't use them in my side projects, but if I had an application that was serving a very specific audience and was really sensitive to latency and all these other things, then it's there for me. But yeah.
definitely. I mean, I do think it's changing really quickly. So as people start pushing more and more things to these edge, functions and stuff like that, we may need. It'll become more prevalent. Like it's clearly like the next step is moving data closer to the edge.